Chapter 4 here, we're going to be getting into atoms and elements. And to me, this is where we really start chemistry. Up to this point, we've been looking at just kind of general science, measurement systems, math to help in chemistry. Here, we're going to actually kind of be diving into the meat of chemistry. And I'll be honest, if we could spend all of our time right here on elements, which are organized on the periodic table, I would. This has become my favorite thing. I mentioned before that I was not a big fan of chemistry as a student. I love teaching. It has become my favorite class to teach. And I am still fascinated with just the basic building blocks there, the elements themselves. I really break chemistry down in kind of 3 sections. Some will say that properties matter. I think of those as belonging to those sections. But to me, it's atoms, elements, periodic table, and then we start to group those things together and bonding, and then we start to break those bonds and rearrange them in chemical reactions. And most people, when they think of chemistry, think of those chemical reactions, but I really think of this is the start of chemistry, and like I said, it's kind of my favorite section here. Unfortunately, I will point out that you're going to get into less review here. Hopefully you know some of it, if not most of it, but we're going to get into less review. We're going to start to get into things that you do have to start to struggle with to learn and memorize, and I'll add with that the pace is going to seem faster because of that, because up to this point, hopefully it's been familiar. And so it may seem like we're plodding along and this is going to be a cinch course. And certainly I want that for you, but at some point in your school career, things just start to not come naturally. You start to have to force yourself to learn things, force yourself to study. And unfortunately, being a college course, especially only spread out over a semester here, the pace is going to pick up here. And like I said, we're not really going faster. It's more that this stuff isn't familiar to you, and so it's going to seem faster because we're covering about the same amount of information, but we go from information that you're at least somewhat familiar with probably to information you're probably less familiar with, and that's just going to continue to be true for the future chapters. Anyway, example slide, pause it if you want. We're going to dive straight into section 1 here, which is elements, and it also mentions the symbols. And so on the periodic table, we have elements that are organized there. Depending on how you count, roughly 90 of them are naturally occurring. That's kind of where I lie, is on the 90 count. And that means we go up to uranium. And there's 2 before uranium, because uranium is number 92 on the periodic table that are naturally occurring. It means there's 2 underneath that are man-made. Above that, all of them are artificially synthesized. They're man-made, and most of those man-made ones are very unstable. They're certainly all unstable, and they don't tend to last very long. They're all radioactive, and we'll get into that stuff when we get to chapter 5, though we're going to jump around the order a bit, and we'll skip 5 for a little while before coming back to it. Every element has a symbol. Some of them have just a 1-letter symbol. If that's the case, that 1 letter is always capitalized. S alone happens to be sulfur, but I'm going just for a generic one here that is SY for symbol. No element on the periodic table has that. 2nd letter, if they have it, it is lowercase. 3rd letter is only a temporary thing. Some older periodic tables will have that 3rd letter on them. Modern ones go out to 118 at least, and all have a symbol for all of them. They've all been given proper names, proper symbols to go with those names. Once that happens, a temporary placeholder name that is based off of the atomic number, it's just the number becomes the name. And so there used to be element 111, and the phrase for 1 was un, and so it became unium. Once we verified its discovery, we gave it a real name, wrote in Gideon, a real symbol, RG, and we no longer had that. But the 2nd letter, if it's around, is lowercase. Same thing with the 3rd letter. If it's around, they're always lowercase letters. That is essential because something like big C, big O is carbon monoxide, a colorless, odorless gas that can kill you without you even realizing that you're breathing it in. You just fall asleep and you don't wake up. Or big C, little o, cobalt, a shiny gray magnetic metal. And so huge difference there. There's all sorts of other examples like that. And it's just for clarity's sake as well. You'll notice, again, as I said, most elements' names match their symbols. Unfortunately, ones that have been known for a long time, ones that have been known since ancient times, like iron, silver, and gold, those famously all have symbols that don't match the name. And unfortunately, they are your more common ones because they've been known for a long while. Well, why were they known back then? It's because they are easy to come across. There's about a dozen of those. There's also about a dozen one-letter symbols, and everything else is a two-letter symbol that roughly at least matches the name. C is overused on the periodic table, and so there's times where we have something like cesium and we have to go to a second or third letter to get to a reasonable symbol because CE was already a thing. And the British way of spelling cesium is CAE. Well, CA was already a thing as well. And so it's not going to be a perfect match for the name always, but it's not super confusing. I will say you're going to be allowed a periodic table when it comes to things like test, and so it might be annoying to have to look through all 118 to find them, but they're going to make sense. Elements are pure substances from which everything else is built. The old joke is don't trust an atom, they make up everything. But everything is made up of atoms. Everything is made up of chemicals then, if you want, and so on. They can't be broken down into simpler substances. Now, I do want to point out that they are made up of smaller pieces, and we'll get into those here in this chapter, but those smaller pieces are unstable and will reform into a atom, a element then of some sort. We have atoms of different elements. And yeah, there's a list inside the textbook, big surprise. There's also a periodic table inside the textbook, and sulfur there as an example. Here are some element names and symbols, as well as where the name came from. I will point out uranium has a fascinating story as to why it was named Uranus, and I'm not going to suck up your time here with that, but I'd encourage you to look it up. It's a little bit more than just a planet. The goal was to make the planet name stick, but anyway. And so you have a lot of times the things are named after places, they're named after mythology, they're named after colors, they're named after where they came from, they're named after people, especially for the modern ones where they're being man-made anyway. Usually they're not named after the people who discovered them because you're not allowed to name elements after yourself. Right here's that example I just gave, the difference between cobalt and carbon monoxide. Carbon monoxide, I will point out, is made up of carbon and oxygen, two separate elements. Every substance is made up of groups of atoms. And again, as I mentioned, 1 and 2 letter symbols. Here's a list of some. Periodic table is a better way to see that because it will actually have all of them. And they do point out that some of them are derived from other languages, mostly Latin and Greek, and that's why their names and symbols don't match. Some of them get their symbols from Latin names. I don't think we need to worry about that. We've mentioned already. Pause and read the details if you want. Here, it's just going to be look up the symbols on a periodic table. Certainly there's some that are common enough that it probably wouldn't hurt to memorize them, or where you'll accidentally end up memorizing them as you go. I probably should have pulled up a periodic table and showed you how to search it, but you just skim and skim and skim until you find it. I will say I tend to put serifs on my eyes, the hat and base, so that it doesn't get confused with an L or a 1. It's not absolutely necessary. I think I mentioned it before as well, but I cross my Z's because my handwriting's sloppy enough that it sometimes looks like a 2 if I'm not careful with the angles on them. The names here, phosphorus. I will say that one's frequently misspelled. Argon by people. Manganese. You have to be careful. It's very similar to magnesium. And those are probably the 2 with the most similar names that you'll commonly come across. There are others. It's that simple. I like to talk about mercury, so I'm going to spend a little bit of time on this one, but mercury is toxic. It's the only liquid metal on the periodic table. There's only 2 liquids on the periodic table. There's a couple others that are close to their melting point, and if we just had a slightly warmer atmosphere, they would warm up. There's a couple where they literally will, or at least one where it literally will melt in your hand. But mercury can be get into your body a handful of different ways, and all of those cause problems because your body doesn't have the ability to remove heavy metals, and mercury is just easier to get in there because it's already in the gaseous state, as we talked about, so it's easier to inhale it, whereas with other metals you have to actually kind of consume them. Many of them don't soak into the skin, but it does cause brain damage and damage to other organs, and it can last in there. I'll point out Alice in Wonderland. You have the Mad Hatter, and there was an old phrase, mad as a hatter, because hatters would go crazy, and it was realized eventually that it was because of what they were using. At the time, hats were commonly felt, so if you think of Abe Lincoln's stovepipe hat, that was a felt hat. Well, to keep the fibers together in felt is not a woven fabric the way that other fabrics are weaved together. It's kind of just random chaotic particles that are held together by friction, but then it's fairly easy to tear felt because of that. And so to help preserve them and to help get them to lock together and help them to not get super fuzzy, they would be dipped in a solution, that is something dissolved, of a mercury compound. It wasn't mercury metal itself. They weren't dipping it straight into the shiny silvery metal. I believe it was mercuric chloride, which is just a mercury bonded to a couple of chlorines, and they dip it in there, and that would help preserve it. While repeatedly putting their hands over and over and over again into there, it's soaking into the skin, breathing in the fumes. It was depositing in their body, and it would cause them to have that brain damage and go crazy. And so the Mad Hatter in Alice in Wonderland is that origin, and it was a real problem at the time when Lewis Carroll wrote the story. Now mercury is banned a lot of places, much harder to come across and handled much more carefully. In Ohio, we're not allowed to have mercury thermometers in school buildings anymore, and they're trying to phase it out everywhere else where it is used because it is so problematic. But boy, is it fun to play with a liquid metal, and you can see how shiny it is. It just looks absolutely awesome to have something that's so mirror-like and yet a liquid that you can squirt and pour out. Anyway, that finishes up section 1.